See here, a person wants a real image of his own 3 times enlarged. Where should he stand in front of a concave mirror of radius curvature 30 centimeter? So here the real image of his own, he wants to get 3 times enlarged one image. Okay. Where should he stand in front of concave mirror? Means the image object distance you have to calculate, but the radius of curvature is given as, that is 30 centimeter. Radius of curvature is given as 30 centimeter. Okay, so here you can see the one, that is, as again it is a concave mirror. So here for the concave mirror, the radius of curvature is taken as minus 30 centimeter. The focal length will be r by 2. So that will be minus 15 centimeter agate. Okay, so the magnification is something they have specified in the question. He wants to get a real image which is of the 3 times enlarged one, right? So for that reason, here the magnification is equal to, it is minus 3. Okay, but we know that the magnification is given as what? Minus V by U. But m is given as how much? It is minus 3, which is equal to minus V by U. So minus minus we can cancel here. Therefore, we can get it as 3U is equal to V. So this is our V value. Now we can use the mirror formula to calculate the object distance, right? So therefore, it is 1 by V plus 1 by U is equal to 1 divided by F. We can substitute all the values. F is equal to minus 15 centimeter. And V is equal to 3U, and you can substitute U as it is. So 1 upon 3U plus 1 upon U is equal to 1 upon F. So here if you substitute the value of focal length, and if you simplify here, the U value will be minus 20 centimeter. You can see the simplification there. So according to the answer, he should stand 20 centimeter in front of the mirror. Okay, so as you are getting the answer as minus, which means that he should stand on the left side, means in front of the mirror. Okay, so copy down the solution here. If any doubt is there in the solution, you can ask your students. So therefore, option B is the right answer here. Once if you have copied down, please tell me. We will go for the next question. Okay, next question. Yes. See here, if epsilon naught and mu naught are the permittivity and permeability of free space, and epsilon and mu are the corresponding quantities for a medium, then refractive index of the medium is. So here the refractive index of the medium we need to see. Here the permittivity and permeability is given as mu naught and epsilon naught. For the free space and for a medium, it is given as epsilon and mu. Then what is the value of the refractive index? A or C? Yes, A is the right answer. So here, as we know that is the refractive index will be given as. So refractive index formula is what? That is the speed of light in vacuum to the speed of light in the medium, right? So now C is equal to, we know that see here, that is the velocity of light in the for the free space is given by 1 divided by under root of mu naught epsilon naught, and V is equal to, it is 1 divided by under root of mu epsilon. So the refractive index, according to the definition, it is given by C by V. So we can substitute C by V value. Here we can see option A is the right answer. That is under root of mu epsilon upon mu naught epsilon naught. So option A is the right answer. We're going for the next question. See, a plain glass plate is placed over a various colored letters. Like we have the colors like violet, green, yellow, red. The letter which appears to rise more is. So this is again based on the refractive index concept. So here what we are seeing here, that is a plain glass plate is placed over a various colored letters. Here whatever the letters are there, they are in the different colors. So the letters, for example, if it is A, B, C, D, you can imagine the letters are, first letter is in the violet color, then the next letter is in the green color, the next letter is in the yellow color, the next letter is in the red color. The letter which appears to be raised more is. So this is on that the glass plate is placed. So which letter appears to be raised? So the options given are red, yellow, green, and the violet. So this is your answer. Option D, that is the violet, or it is red. Yes, it is option D, that is violet is right answer here, because according to the dispersion, if you see the dispersion phenomena, the red is the most deviated and violet is the least deviated colors, right? So here you can see that one. Going for the next question, students. So focal length of a convex lens is 20 centimeter. Focal length of a convex lens is 20 centimeter and its radius of refractive index is 1.5. It produces an erect enlarged image if the distance of the object from the lens is. Yes. See what it is given. A convex lens is given as a convex lens. Focal length is given as 20 centimeter and its refractive index is given as 1.5. It produces an erect enlarged image if the distance of the object from the lens is. See, a convex lens produces an erect enlarged image if the object lies between focus and the focal, right? So hence U is equal to, it is 15 centimeter. U is equal to, it is 15 centimeter. See the next question. A ray of light suffers a minimum deviation when incident on an equilateral prism of refractive index root 2. The angle of incidence is, so what is the value of the angle of incidence? See, a ray of light, it suffers a minimum deviation when incident on an equilateral prism of refractive index root 2. Here the angle of incidence. So if you remember the derivation for the prism formula, so there we will get one step. So which gives the relation between the refractive index, angle of incidence and the angle of minimum deviation. So by using that we can calculate, see here. So according to the formula, the angle of minimum deviation is equal to, so this step will come in between the derivation, E step. Okay, that is angle of minimum deviation is equal to 2I minus A. So remember this as equation 1. Here A, it is given as A is equal to 60 degree. Okay. So now according to the prism formula, that is the refractive index is equal to sine of A plus delta M divided by 2. This whole divided by sine of A by 2. Okay, so A is equal to 60 degree, then mu is equal to, or that the refractive index is equal to given as root 2. So root 2 is equal to sine of 30 plus delta M by 2. Okay, so this whole divided by sine of 60 by 2 is nothing but sine of 30 degree. So later this sine 30, if you transfer here, you will get, and that is 1 divided by root 2. So 1 by root 2 is nothing but what? That is sine of 45 degree. So again, sine we can cancel on both the sides. So we will get it as 30 plus delta M by 2, which is equal to 45 degree. So the of minimum deviation is equal to 30 degree. But ನಮ್ಗೆ ಏನು calculate ಮಾಡಬೇಕಾಗಿದೆ students ಇಲ್ಲಿ, we need to calculate the value of the angle of incidence. So you can use the equation 1. So therefore here I is equal to A plus delta M by 2. So therefore I is equal to 45 degree. So little network issue is there today. Yes, option B is the right answer here, students. You can copy that solution part. If any doubt is there in the solution, please ask. The next question. Scattering, the amount of scattering is inversely proportional to that of the wave of the light. So this is based on the Rayleigh's scattering. So if you don't know this, that is option D is the answer, students. So during the scattering of light, amount of scattering is inversely proportional to 4 power of the wavelength of light. So this is also called as Rayleigh. You can write on this point.